Hello, this is a video on how to do molar mass calculations. So a molar mass is exactly what it says it is. It's the mass you have to weigh out of 1 mole of something. It's a general name for various other word sets depending on what kind of substance you have. If it's an element, we call it atomic mass. But besides that, there is just a large number of different names you give the mass of 1 mole of something. Molecular weight is a very common one. But any way you look at it, what you're doing is you're trying to figure out the mass you have to weigh out of 1 mole. So you're assuming 1 mole, and now what you have to do is figure out what the mass is. The one concept you have to use here is the concept of particle ratios. So for example, if I were trying to find the molar mass of H2O1, what you have to realize is that in one molecule, right here, 1 molecule of H2O, there are 2 atoms of hydrogen. Well, since there are a lot of atoms and a lot of molecules, and any amount you weigh out, what chemists have done is they've created the concept of the mole. The mole is 6.02 times 10 to the 23rd of anything. And since we have 2 atoms of H, then in 1 molecule of H2O, if we have 6.02 times 10 to the 23rd molecules of H2O, we would have 2 times that number of atoms of hydrogen. But we wouldn't usually write those numbers. What we would usually say is that there are 2 moles of H in 1 mole of H2O. And that concept we'll use in this discussion. Because what we want to do is we want to break it up into each element separately. So what actually you have is 2 moles in water, 2 moles of H and 1 mole of H2O, and you want that because we know the atomic mass of hydrogen, which means 1 gram, if we weigh out 1 gram of H, we have 1 mole of H. So therefore, if you multiply all this, you get the mass of hydrogen in 1 mole of H2O. Then what you're going to do is you're going to add it to the next element, and you keep on doing this for each of the elements. So so for the second one, oxygen, what we have is we have 1 mole of oxygen and 1 mole of H2O. And again, the atomic mass of oxygen is 16 grams of O and 1 mole of O. So that when you do that multiplication, you end up the mass of the O, all the O, and the whole molecule, 1 mole of H2O. And then what you do is add them up, because there's only 2 elements in this compound. So you end up with 18 grams of H2O you need to get 1 mole of H2O, and there is your molar mass. The amount you have to weigh out of water to get 1 mole of water. In this case, it's 18 grams. So that's all the units. So to make it easier, what I have done is I've basically said, you don't have to do all the unit thing. You can shorten it down. So what I expect to see is this, which is the molar mass of H2O, okay, dot, 2, so this whole thing is replaced by 2 times 1 gram of H, which is the atomic mass, plus 1, and there's oxygen, in parentheses, 16 grams of oxygen, again, the atomic mass of oxygen is just the grams part, is equal to 18 grams of H2O1 and 1 mole of H2O1. It's very important that you make it a ratio. because that's what the molar mass is. It's a ratio of grams of something to 1 mole of something. That's the conversion factor you're going to use, and the reason why you're using it, because some reason you want to go from grams to moles and moles to grams. Now, as you know, in the first year level, everything is rounded. All the atomic masses are rounded to the whole number except chlorine. So there's a special case when you were dealing with chlorine with odd subscripts. Okay, for example, sodium chloride, Na1CO1. So 1, this 1 Na times the atomic mass of sodium, 23 grams, plus 1 times the atomic mass of chlorine, which is 35.5 grams. And what you get is you get 58.5 grams of Na1CO1 and 1 mole Na1CO1. Okay? And the thing is, if you have an odd subscript, you will always end up with a 0.5. So you're going to write it down, and then you round it to the whole number to make it 59 grams of Na1CO1 and 1 mole of Na1CO1. Okay? And you're going to do that any time that your Cl has an odd subscript. Because if it has an even subscript, you're not going to end up with 0.5, you're going to end up with just a whole number. So that's the only time where you're going to do that. And it's after you have added everything up. Okay? And again, you have a mass per mole of something. That is the molar mass in how you calculate it. So that's my expectations. Thank you.